Mars, the red planet. Our next home? For decades, scientists, dreamers and billionaires have promised a future where we terraform Mars, where we melt its ice caps, thicken its atmosphere and turn its frozen desert into a second Earth. But what if I told you it's never going to happen? At least, not in our lifetime, and maybe not ever. The idea sounds incredible. A planet-wide engineering project to make Mars habitable. But when you break down the science, the challenges aren't just difficult, they're practically insurmountable. From deadly radiation to Mars's missing magnetic field, the universe seems rigged against us. So today, let's crush the sci-fi fantasy and look for the cold hard reasons why Mars will soon be a dead planet. Chapter 1. The distance problem. Why Mars is too far to save us. Let's start with the most obvious problem. Mars is really far away. Even at its closest approach, it's still 34 million miles from Earth. That's like circling our planet 1,400 times. And that distance isn't just an inconvenience, it's a death sentence for any hope of a quick resupply or rescue. The journey there, a one-way trip isolation. With current technology, a trip to Mars takes roughly 6 to 9 months, longer than early explorers spent crossing the ocean. But unlike those voyages, there's no turning back. If something goes wrong, food spoilage, oxygen leaks, engine failure, help is years away. And that's just a trip. Once you're there, you're stuck waiting 26 months for the next launch window to return. Food, water, oxygen. The math doesn't add up. On Earth, we take food for granted. On Mars, however, every calorie must be shipped or grown, and both options are disasters waiting to happen. Shipping supplies? A single astronaut needs 1 ton of food per year. For a small crew of 10, that's already 10 tons of food per year, requiring multi-billion-dollar launches just to avoid starvation. How about growing the food? Well, Martian soil is toxic, filled with perchlorates that poison plants. Even in controlled labs, crops grow weak and stunted. And if your hydroponic farm fails, you starve. The psychological toll. Isolation, madness, and no escape. Forget physical survival. What happens to the human mind? Studies in Antarctic and space simulations show depression, conflict, and mental breakdowns are inevitable in a long-term isolation. On Mars, there is no blue sky, no fresh air, no escape. Just a cramped habitat under a deadly sky. Even the most resilient astronaut would crack under that pressure. Chapter 2. Radiation. Mars's invisible death sentence. Imagine this. Every second you spend on Mars, invisible bullets are tearing through your cells. Not metaphorically, literally. Without Earth's magnetic shield, Mars is bombarded by deadly radiation and there is no way to hide. The trip there, a deep space radiation bath. Even before you land, the journey to Mars is a cancer risk. In just a 6-month trip, astronauts absorb 60% of their lifetime radiation limits, equivalent to getting a full body CT scan every 5 days. Solar flares make it even worse. A single storm could deliver a lethal dose in hours, and warning systems give just 30 minutes in advance. On the surface, no shield, no mercy. Earth's magnetic field deflects cosmic rays. How about Mars? It has lost its magnetic shield billions of years ago. Today, radiation on the surface is about 40 to 50 times higher than on Earth. Spend a year on Mars and you'd absorb 50 times as much as nuclear workers' annual limit. DNA damage, sterility, and a sky-high cancer risk come standard. Underground or doomed? Spoiler alert, still doomed. What if we live in caves or lava tubes? It helps, but not enough. Even 10 feet of rock only cuts radiation by half. Stay underground for too long and you face muscle atrophy, depression and vitamin D deficiency, trading radiation sickness for a slow physical decline. The unfixable problem. No magnetosphere, no future. Here's the kicker. Even if we block radiation today, Mars's lack of a magnetic field means that any atmosphere we will create will get blown away again, just like last time. NASA estimates Mars lost its air because the solar wind stole it over millennia. Artificial solutions, like a giant space magnet, are pure sci-fi, requiring technology we won't have for centuries. Water, oxygen, fuel? On Earth we take them for granted, but on Mars, every drop, every breath, every spark of energy has to be clawed from a planet that is actively fighting against us. Water. Trapped, toxic, or non-existent. Yes, Mars has water, but it's either locked in the polar ice caps or buried in toxic sludge. Mining ice requires heavy machinery, insane energy, and perfect conditions, things we won't have in early colonies. The soil is laced with perchlorates, chemicals that destroy human organs. Purifying it? A nightmare. Without a steady water supply, no farming, no drinking, no survival. Oxygen. MOXIE isn't enough. NASA's MOXIE device proves we can make oxygen from CO2 at a snail's pace. MOXIE produces 6 to 10 grams per hour, enough for one person to breathe for roughly 10 minutes. Scaling up, you would need 1,000 of MOXIE units running non-stop just for a small crew. And that's just breathing. What about fuel, industry, emergencies? The math collapses. Fuel and energy, the power problem. Maybe solar power is the solution. Well, Mars has dust storms that block sunlight for months, so you will spend months without any energy. How about nuclear? Well, shipping reactors to Mars is insanely risky. What's the result? Energy shortages mean no heating, no food production, and no backups when the system fails. The bigger picture. Mars is a resource desert. We've tried closed ecosystems on Earth. They failed miserably. Now imagine doing it on a planet where the soil is poison, the air is thinner than Everest, and every mistake means death. All of Mars's problems so far, they're fixable. In theory. But this one? This is the deal breaker. Mars has no magnetic field, and without it, any hope of terraforming is just fantasy. Earth's shield versus Mars's vulnerability. Earth's magnetic field is an invisible force field deflecting deadly radiation and solar wind. How about Mars? Well, Mars lost its field billions of years ago, and the results were catastrophic. NASA data shows that Mars's atmosphere was stripped away by solar wind, leaving it a frozen desert. Even if we somehow thickened the air, the solar wind would just steal it again, just like last time. Artificial solutions? More like sci-fi dreams. Some propose building an artificial magnetosphere, a giant space magnet to deflect solar winds. Sounds cool, right? Here's the problem. The scale is unimaginable. We're talking about a structure millions of times more powerful than anything we've ever built in space. The energy requirements are absolutely impossible. It would need more power than all of humanity currently generates. And what if it fails? The atmosphere gets shredded and everyone on Mars would die. The ultimate conclusion: Mars can't be Earth 2.0. Without a magnetic field, Mars will never hold a stable atmosphere. No atmosphere means no liquid water, no breathable air, no protection from radiation, just a slow, inevitable death for any long-term settlers. Terraforming isn't just hard, it's fundamentally impossible with the laws of physics as we know them right now. Mars is a graveyard. A beautiful, fascinating, scientifically priceless graveyard. But a graveyard nonetheless. The hard truth we need to accept. After everything we've covered, the radiation, the lack of water, the missing magnetic field, one thing is clear. Mars will never be our backup planet. Not in our lifetime, not in our grandchildren's lifetime, or maybe even never. And that's okay, because obsessing over Mars distracts us from the real crisis, the planet we are already on. The irony of escaping Earth. Think about it. We're considering moving to a dead world because we've made our own world harder to live in. But here's the thing. Fixing Earth is still infinitely easier than terraforming Mars. We already have air, water, a magnetic field. All we're missing is the will to protect it. Where do we go from here? We should reverse climate damage with clean energy and carbon capture. We should restore ecosystems instead of trying to build them from scratch in a toxic desert. And we should ensure our survival without gambling on a pipe dream.